Now I am going to discuss under acceptance sampling part 1 an important topic called the design of sampling plans, and with numerical exercises. And as I have already told you that there are the two kinds of sampling plans you come across. One is the general purpose the sampling plans we have already referred to, like single sampling plan, double sampling plan, multiple sampling plan. But you need to use the different the special purpose the sampling plans under the special conditions. So we will be discussing certain the special purpose sampling plans. In specific terms, we will be referring to chain sampling plan, sequential sampling plan, as well as the plans for the continuous production. Okay, so this will be our coverage in this particular the lecture session. Now, the design of sampling plan is a very important issue. Whenever you try to use acceptance sampling the techniques in your workplace, obviously you have to select appropriate sampling plan, and while you select an appropriate sampling plan, you also must know as an expert, as a learner, the design procedure of a sampling plan. That means how to design a sampling plan you must know, and then only if the design process is known to you, then only it is most likely that the selection of an appropriate sampling plan is based on scientific logic and the selection is proper. So any sampling plan is defined in respect of its parameters. We have already pointed out. While lot size is specified, it is pre-specified, whether it is 2000 or 5000 or 10,000 capital N, we need to determine the values of the parameters in such a way that the certain conditions are fulfilled. Okay, so any design exercise when you carry out, okay, obviously this design exercise is carried out to meet certain goals or to meet certain objectives. For example, you may determine the parameter values of a single sampling plan such that the conditions or the criteria in respect of producers and consumer risks are met. Is it okay? We have already pointed out that there will be producers risk, there will be consumer risk. Okay, whatever may be the design quality of a sampling plan. So what you need to know, that means you specify the acceptable values of alpha and acceptable value of the beta, and then you need to design, you need to recommend a sampling plan. So this there could be many other the such a criteria you need to use or need to consider while you design a sampling plan. The procedure employed to determine the parameters in this context is referred to as designing a sampling plan. Is it clear? 4 values must be specified, as already pointed out, right? The alpha, beta. What is alpha? Alpha is the producer's risk. What is beta? Is a consumer risk. What is P1? That means P1 is considered to be a very good quality. So it may be considered as AQL, acceptable quality level. And P2 may be considered, could be a bad quality or the poor quality, and this may be referred to as LQL, limiting quality level. The OC curve must pass through the 2 points. That means suppose you specify all these 4 values and you design a sampling plan. Against a sampling plan, you need to construct the OC curve, and this OC curve must pass through all these 2 points, that is 1 minus alpha P1 and beta P2. Is it okay? So this point already we have elaborated when we were discussing the OC curve. Now how to determine the values of the decision variables? Using binomial distribution, that means you are considering a series of lots, we have the following equations. That means what is 1 minus alpha? That means when the probability, so this is I equals to 1 to C, okay, and that means the C is the acceptance number, and the value of say the non-conforming in a particular sample may be 0 or maybe 1 up to the acceptance number, that is C. So NCI P1 to the power I into 1 minus P1 to the power n minus I. Is it okay? Similarly, if it is beta, that means this is sigma I equals to 1 to C, and I varies from 0 and C is the acceptance number, NCI P2 to the power I into 1 minus P2 to the power n minus I. That means these are the 2 equations you have, and how many unknowns you have? You have the unknowns of C and unknowns of n. Is it okay? So that means what are the parameters? The parameters are the sample size n and the acceptance number C. So you have 2 equations and the 2 unknowns. Now the unknown variables are n and C. Both these equations are nonlinear, and hence solving them simultaneously for n and C will not produce in all likelihood a direct or a closed form solution. Is it okay? There is a high chance that you will not be getting a closed form solution. Hence such a direct analytical approach is always preferred, but in this case what you see or what you observe is that the analytical approach may not provide or may not lead to a closed form solution. So hence in this particular context a direct analytical approach is avoided in view of the practical difficulties. Is it okay? So one may have to use a trial and error procedure so that both the equations can be satisfied simultaneously as closely as possible. So while you design a sampling plan, you will find that we will be adopting the trial and error approach, okay, instead of adopting analytical approach. I think the reason is very clearly understood, that why we are preferring adopting a trial and error approach. A sampling plan is to be designed so that one or more criteria are to be satisfied. Is it okay? Like say criteria like alpha or criteria like say the beta. Hence while we proceed for designing a sampling plan, these stipulated criteria are to be known. That means what are those stipulated criteria you must know. We explain the procedure of designing a single sampling plan under the following 3 specific conditions. Is it okay? Say the condition 1, stipulated producer's risk with AQL. That means the designer wants to design a sampling plan in such a way that the producer's risk condition is satisfied as stipulated. Condition 2 is you are bothering about the consumer risk, you are not bothering about the producer's risk. So you design the sampling plan in such a way that the stipulated consumer risk condition is satisfied. So obviously when you define consumer's risk, you refer to LQL. It must be defined with respect to the LQL. Similarly, you may face a situation called face the condition 3, that means the stipulated producers and consumer risk. So okay, so 3 cases we will be referring to, and we will give you the solution approach or the design approach. For all these 3 cases we will follow the trial and error procedure. Okay. The procedure is as follows. Select a sample size of 1, C equals to 1, PA is equals to 1 minus alpha for P equals to AQL. Assuming Poisson approximation to binomial, we get the values of lambda. Lambda is equals to n into P. Is it okay? From cumulative Poisson distribution table for x equals to 1, because C is 1, that means x is equals to 1 if you refer to the Poisson distribution, cumulative Poisson distribution table. As lambda equals to np equals to n into AQL, this unknown n will be known. Okay. Hence, again C equals to 1, n is known. The value of n will be specified. Repeat the procedure as outlined in 1 for two other values of C, say C equals to 3 and C equals to 5, to determine the corresponding values of n. Is it okay? Right? So, as C increases, n also increases. As both C and n increase, the OC curve becomes stiffer, and hence with increased NC values, the value of consumer's risk is less. Is it okay? That means if you have the stiffer OC curve, what you will find that the consumer risk, okay, at a particular value of LQL is expected to be very less. However, as the sample size n increases, for a better protection against consumer risk, the inspection time and cost may be higher. Is it okay? So that's why we always prefer, that means whether we make a decisions whether you will opt for higher values of n or say the lower values of lower value of n. So based on preference given to protection against consumer risk, the protection against consumer risk will be very high if the sample size is more. But against, if the sample size is more, the inspection time or the inspection cost may be higher. So that's why you have to make a decision that which one we will opt for, and accordingly you decide that what is the best combination of n and C. Is it okay? In the conditions 2, that is stipulated consumer risk with LQL, same procedure is followed under condition 1 is to be used. However, while deciding on the combination of n and C, you need to determine the possible protection level against producer's risk. Is it okay? For each combination, and based on performance given to protection against producer's risk, okay, or inspection time or cost, the combination of NC is selected. Is it okay? So so there's the same thing you repeat, but only thing here means the consumer risk criterion say that you fulfill, but you check that as the sample size increases, what might happen that the producer's risk has come down, but then if the sample size is more, the inspection time and the cost could be higher, and that may not be acceptable to you. So the condition 3 is the both producers and consumer risks you have to meet. So in this case, both the criteria need to be satisfied. However, as the criteria are specified without knowing the shape of the OC curve, it is most likely that both the conditions cannot be satisfied exactly. So this is the point to be noted. You have two choices. Either you determine NC in such a way that it satisfies the producer's risk criterion exactly and the consumer risk criterion approximately as close as possible, or vice versa. Okay, so the choice is yours. So you have two choices. You have to adopt just one of these two choices. The procedure as laid out for condition 1 or condition 2 is to be followed for determining the combination of NC. Is it okay? So please go through this example, and this example is related to finding a single sampling plan that satisfies a producer's risk of 5%, for lots that are 1.5% non-conforming. So what is the solution? So here alpha is 0.05, P1, that is AQL, is 0.015. If we choose an acceptable number C equals to 1, for which table 1 gives NP1 is equals to 0.355, the sample size is this. Is it okay? That means this value you get from the cumulative Poisson means the n value you get, that is the lambda is 0.355, and this is the P1, that is 0.15, that is 23.67, that is 24. Is it okay? It is approximated with 24. Round it up. For our acceptance, if acceptance number is 3, we have NP1 is equals to this one, and the sample size is n equals to this. That means corresponding lambda values, right? And it is 91.07. So how do you get these values? That means here it is 95%. That means when the if you refer to the Poisson cumulative Poisson distribution table against a particular value of say the probability of acceptance and a particular value of say x is already given. Okay, so so that is C equals to 3. The corresponding value of lambda you can read from the table, and that value is 1.366. Is it okay? Similarly, when the acceptance number is changed to 6, that means x equals to 6, probability of acceptance is 0.95. So if you refer to the cumulative Poisson distribution table, you can get the value of lambda, and that value of lambda is 3.286. So if C is 6, n is 220. Is it okay? So these are the possible values, and so when PA is 0.95, NP1 corresponding values, PA is 0.10, NP2 that is related to the consumer risk, and NP2 by NP1, these possible values you compute. Is it okay? And then the OC curves for a single sampling plan, so stipulated producer's risk and AQL. So this is one example we have provided. So this figure shows the OC curves for the 3 sampling plans. Note that all 3 plans satisfy the producer's risk of 5% at the AQL value of 1.5%. Is it okay? So you just follow these examples. Later on I'll give you several the numerical exercises related to this, and when you follow all these steps, your understanding will be very good, and you will know that how to design a single sampling plan, what the procedures you have to follow. So so here this point is that they have varying degrees of protection against acceptance of poor quality lots, which would be of interest to the consumer. Now of the 3 plans shown, n equals to 220, C equals to 6 provides the best protection to the consumer. This point we have already elaborated. As the sample size increases, so you will have better protection against consumer risk. However, it has the lowest probability of accepted poor quality lots. We must also consider the increased inspection cost associated with this plan, because the sample size for C equals to 6 is the largest of the 3. So you have to make a trade-off. So so this is the procedures we follow, and what we are saying that you select the values of C in such a way that they are feasible. Designing a sampling plan based on other types of criteria is also recommended in standardized sampling plans, as given in Dodge-Romick plans. 2 such criteria are as follows: stipulated consumer risk beta with minimizations of ATI, stipulated AOQL. We have already explained what is AOQL with minimizations of ATI. So ATI already we have explained, and similarly you know what is the consumer risk and the stipulated AOQL. So these 2 the sets of criteria also they have considered while they propose the sampling plans with rectifying inspection. Now let us discuss the special purpose sampling plans. There are many the different types of say the special purpose sampling plans already developed by the several researchers, several practitioners, as well as the several organizations. So out of all these special purpose sampling plans, we will be referring to just three. These are all important. In fact, you must learn all these three types of special purpose sampling plans. First one is the chain sampling plan, next one is the sequential sampling plan, and the third one is the continuous sampling plan. Under continuous sampling plan, you have these the 5 varieties as per the standards, that is CSP1, CSPF, CSP2, CSPT and CSP5. So briefly I will explain all these special purpose sampling plans. Now the chain sampling plan is recommended when the value of C is 0. Now the value of C may be 0 when the sample size n is very small, less than equals to 10, due to the use of destructive testing inspection, or the production rate is very slow. So if the sample size is less than equals to 10, say 8 or 7, in all likelihood you will find that you suggest that the acceptance number must be 0. If you use a typical single sampling plan, the OC curve is convex, and hence even if with a slight change in incoming lot quality, there may be substantial change in the probability of acceptance. This point already we have elaborated. The situation is not acceptable in majority of the cases. So the best alternative under this constraint is the chain sampling plan. The working of this plan is as follows. A random sample of size n is drawn from a lot, and this the sample size is very less than equals to 10. If the number of non-conforming units found, that is x is basically a random variable, x equals to 0, then the lot is accepted. If x is greater than equals to 2, then the lot is rejected. If x equals to 1, then the lot is accepted, provided each of all the previous I number of samples drawn has no non-conforming units. Is it okay? So it is conditional. So how do you compute the probability of acceptance of a lot? So when the working of the chain sampling plan is as explained, that is, the probability of acceptance is probability that there will be 0 non-conforming in n number of units plus probability that there will be 1 non-conforming unit in n number of units, that is the sample size, provided that the previous I number of samples, okay, all are having 0 non-conforming in the sample. So this is the condition, and you must have this condition, and with this condition, even if in the current sample you have 1 non-conforming unit, you are going to accept it. Thus the shape of the OC curve is indicative of inverted S and hence acceptable. The shape is however dependent on the value of I. The parameters of the plan is sample size, the acceptance number, that is 0, and you have to specify the value of I, whether it is 1 or whether it is 5, that you have to specify. So here is just an example. What you find that this is a typical single sampling plan with n equals to 10 and c equals to 0. So you have this curve, OC curve, that is convex. So this is not acceptable. What you do, you go for chain sampling plan. So sample size is 10, and this the rules you follow for acceptance, and you just vary the value of I. So when the I equals to 1, you will find that the shape of the OC curve is like this. Whereas if you go for say I equals to 2 or 3, 4 or 5, as you increase the value of I, you will find with the increased value of I, the shape takes the inverted S form, and that's why it is accepted. So it is now what is the sequential sampling plan? So it is an item by item or unit by unit sampling plan. Is it okay? Till now we have considered the lot by lot sampling plan. So when you refer to the sequential sampling plan, this is an unit by unit sampling plan. The number of units required for sampling is determined by the results of the sampling process. So at each phase, based on the cumulative inspection results, a decision is made to either accept the lot or reject the lot or continue sampling. The working of such a plan can be described with the following diagram. So this is the diagram you have. That means on the x-axis you get the number of items inspected, and on the y-axis you just get the value of number of non-conforming items or the units. Is it okay? So you have this acceptance line and you have the rejection line, and so this is the acceptance region and this is the rejection region. So you have this equation for the rejection line, you have this equation for the rejection lines. So this is your intercept, okay, minus HA, and this is the intercept for the rejection line, that is HR. So these are the notations we used. N is the number of units you inspect, and what you try to plot, that is the cumulative the number of non-conforming items. So here all these the cumulative number, this is the continuous sampling region, and as soon as you reach the rejection region, okay, so you have maybe you have say inspected around say the 28 units, and you find that the 3 units as the non-conforming units, but already you have reached the rejection region. So you say that I will reject the lot. So these are the equations you have. Please go through all these equations. This is the equation for the acceptance line, this is the equation for the rejection line. What is S? S is basically the slope, and what you need to do, that means you need to specify the producer's risk, that is alpha, along with the value of P1, okay, and good quality, and similarly you have to specify the value of beta along with P2, that is LQL, okay, and then you apply all these the formula, and you get the expressions for say the rejection line, acceptance line, and the slope. This is the expression for slope. So all these details you will come to know, and you can define the sequential sampling plan. Now for continuous say the production, the standard lot by lot the sampling plan is not acceptable, because in a continuous production scenario you cannot form the lot. If you form the lot, what happens, that there could be the disruption in the production system, or there could be the stoppage in the production system. So so the productivity gets lost, and you will not be getting acceptable performance. So this is not acceptable. So what you try to do, that means for the continuous production, if you want to use the sampling plan, you go by unit sampling plan, and what you try to do, that means you apply the different or you use the different kinds of sampling plans. Okay, so so there are two main parameters for a sampling plan. One is the clearance number, and the second is the sampling frequency. So these plans are designed to achieve a certain level of AOQL in the long run for a series of units. So as per military standard 1235C, there are 5 types of such sampling plans under continuous say the production scenario, and these are referred to as the continuous sampling plans. So CSP1, CSPF, CSP2, and CSPT and CSP5. Under this category you may come across other types developed by several companies and manufacturing and service organizations. So this is a typical the CSP1. You start you go for 100% inspection of the units, okay, one by one, and then you check whether the I consecutive units conforming or not. If you achieve this condition, then what you do, that means a condition of consistency is reached. So instead of going for 100% inspection, now you go for the sampling inspection with a sampling frequency of f. Is okay. Now during this phase, if you find any non-conforming unit, is it okay? You will immediately, any non-conforming unit, so you immediately you go for 100% inspection. You immediately go for 100% inspection. So if you go for any 100% inspection, but so long you do not get any non-conforming unit under sampling inspection, you continue with inspection at a sampling frequency f. So this is a sampling procedures we follow. So obviously there are two parameters. One is I, this is called the clearance number, and f is the sampling frequency. Now obviously if I is more, the sampling frequency is less. So so the relationship between I and f is inverse. And what are the possible values of f as given in the standards? That is, it could be half, it could be 1/3, it could be 1/4, it could be 1/5. If it is 1/5, means out of 5 units you come across, you just select one unit for inspection, and this selection is must be a random selection. Okay. So 1/7, 1/10, 1/15, and it may go even 1/200. That means maybe say I value you have considered, that is say 5,000. So what you find that all the 5,000 consecutive units found as non-conforming. So obviously the sampling frequency could be very, very less. Okay, so now there is a variation of CSP1. Now when the production rate is less, what you try to do, that means you opt for CSPF. It's basically CSP1 plan, but it is indexed with the production rate. You go for CSP2, that means in the CSP2 what you do, that means when you it is basically CSP1, but the first time under sampling frequency, when you get a non-conforming unit, you ignore it. Is it okay? But if you get the second non-conforming unit under sampling frequency, definitely you go back for 100% inspection. So that is the main difference between the CSP2 and CSP1. Under CSP-T plan, we can reduce sampling frequency from f to f2 to f/4, provided no non-conforming units are found at each of these frequencies. However, whenever a non-conforming unit is found at any frequency, 100% inspection is restored. In CSP-V plan, a return to 100% inspection is needed whenever a non-conforming unit is found within the first I sampled units when sampling inspection is at a frequency f. Once first I sampled units passed, 100% inspection is restored if S non-conforming units is found thereafter. However, the clearance number is restored by 2/3. Is it okay? That means both CSP-T and CSP-V are used when the process is to be economical by either reducing sampling frequency or by reducing the clearance number. Okay, so the necessary condition, a controllable stable manufacturing process. So all these details, so please the refer to all these special types of sampling plans. There are 3 types we have explained, and related to all these the sampling plans we will have in the numerical exercises later on as a part of your assignment later on. So we are concentrating on 3 special types, that is, one is the chain sampling plan, the second one is the sequential sampling plan, and the third one is the varieties of continuous sampling plans. Mainly the CSP1 we have discussed, and once the CSP1 is known, under several other conditions you may opt for other varieties of continuous sampling plan, or CSP2 or CSP-V or CSP-T or CSP-F. So we conclude our discussions on the first part of the acceptance sampling. In the next week we are going to discuss the sampling plans for say the variables data. That means there are many cases related to a particular quality characteristics. You are collecting the variables data. So how to say the design or how to use a sampling plans when you collect variables data. So this part we will be discussing in the next week.